Hey kids, so today we are going to see some terms related to lenses and the rules for drawing the ray diagram. Okay, so let's start. So what is a lens? Lens is any curved surface. Okay, and how many curved surfaces? Lens is made up of actually curved surfaces. How many curved surfaces do we require to name a particular thing as lens? So we require minimum of one curved surface. Okay, for example, if one surface is plane and another is curved, this is the lens, right? uh, both the surfaces are curved, this is a lens, right? Both the surfaces are curved inwards, again a lens. One inward, one outward, again a lens, right? Okay, and this not a lens. Okay, minimum of one curved surface should be there. Okay, right? Okay, so in our syllabus we need to study a lens, biconvex lens, okay, both side convex, and biconcave lens, so both sides are concave, right? So let's see what are the rules for drawing ray diagram in our syllabus. First, let's understand uh, the different terms which we are going to use. So number one, for being a lens, okay, or suppose being we are taking a convex lens here, right? So convex lens can be made by the intersection of two spherical surfaces, right? So two spheres, the center of those spheres are called as center of curvature. Okay, so our lens will have two center of curvature. Suppose this is a lens, so it will have two center of curvatures, right? A line which will connect these two center of curvatures, we will call this a principal axis, right? Next term is the center of these two surfaces, okay, of the lens. The center of the lens is called as O, optical center. Okay, so let's make this again. So there is the principal axis, we have a lens, convex lens. Okay, here we have a center of curvature 1, here we have center of curvature 2. We also call center of curvature 1 as 2f1, and here 2f2. This is O, right? Okay, and let's now see what is this distance called. See, the distance between center of curvature and optical center is called radius of curvature. By common sense we can say that, see, this is the distance between center of curvature and optical center is called as radius of curvature, right? And then half the radius of curvature is called focus. Okay, by the way, we define focus in some another way too. Suppose we have light rays coming parallel to principal axis, and light rays coming parallel to principal axis, after getting refracted they converge at a point called as focus. Okay, and the focus is on the other side, so this is f2. If suppose light rays were coming from this side, then they would have been meeting here, so this is our f1. So this is twice this length, and that's why it is 2f1 and this is 2f2. Okay, the distance between focus and optical center, the distance between focus and optical center is called focal length, and focal length is always half of radius of curvature, right? It's easy. Okay, suppose we have a concave lens. Okay, then what happens? If there are light rays coming parallel, they get diverge, because concave lens is a diverging lens, convex lens is a converging lens. They diverge, and if someone is looking from here, for that particular person, okay, these rays are diverging rays, and he will get a virtual image, okay, right here. Okay, these rays would be appearing to meet from this particular point, and this point is called as f1. Here at the same distance there will be f2, then there would be center of curvature 2f1, and here somewhere 2f2, right? Now let's hop on to the rules for ray diagram. The rules for drawing ray diagram. So there are three rules. Okay. Suppose this is our lens. This is O, f1 twice the distance to f1, f2 and twice the distance to f2. Right. So if the light ray is coming parallel to principal axis, after getting refracted, they pass through the focus. This is our rule number 1. Rule number 2 is just inverse of rule number 1. If there is a light ray passing through the focus, incident ray is passing through the focus, after getting refracted, that ray, refracted ray, will be parallel to principal axis. Rule number 3 is interesting. If there is a light ray passing through the optical center, it will go on continuing its path without being refracted. So these are three rules based on which we will draw our ray diagrams. Do your best, keep practicing. We'll see you next time.